Welcome back to section 10.5. We just finished multiplying radical expressions, and now we're going to move to dividing them. Sorry for the large amount of text here, but how do you divide radical expressions? Basically, the problem with dividing, it's not going to feel like we're dividing. What we're going to be doing is rationalizing, because the main issue with dividing is that is the simplifying part, because you're not allowed to have a radical in your denominator in simplest form. And so really what we're going to be doing with dividing is we're just going to be trying to get rid of radicals in the denominator. So how do you do that? Well, if there's just one term in the denominator, you're going to be multiplying by that root however many of times you need in order for it to be a perfect square or a perfect cube, in order to get the groupings that you need to take it out of the radical. Well, what if there's like two or more terms? What do you do then? Then you multiply by what's called the conjugate. And the conjugate has the same two terms, but just different signs. And so this kind of goes back to factoring. When you think about the factoring of the difference of two squares, perfect square minus perfect square is a plus b times a minus b. And so that those same two terms multiplied together where they have different signs in the middle, what ends up happening is those middle terms will cancel out and you'll have perfect squares on each end, which will take things out of the square root. So, I think this will make more sense as we do a few. So, let's try them. So, I'm just going to start with example 2 with things that just have one term in the denominator, okay? So, part A, here we've got 5 square root of 6 over the square root of 5. When I divide, it's not going to be pretty. You know, we just have like a 6/5, which just ends up with a fraction, which doesn't help anything. So our main goal right now is just getting that square root out of the denominator so that we don't have any square roots down there. So we can be in simplest form. So if I want to get rid of that square root of 5, what I'm going to do is I'm going to multiply by the square root of 5. Because then I would have the square root of 25, which is a perfect square, and that takes it out of the square root. The thing, though, is that if you multiply the denominator by something, you've got to multiply the numerator by the same thing to keep it equivalent. This is multiplying by a fun version of 1. So you're multiplying the top and the bottom by the same thing, so it stays equivalent, okay? So once I do this, I'm going to have 5 square root of 6 times the square root of 5. I'm going to do outside times outside. 5 times 1 is 5. Inside times inside. 6 times 5 is 30. And the denominator, we talked about this, you're going to get the square root of 25, which is great, because that's a perfect square. And the square root of 25 is just 5. And that's nice. Then, we actually have a little bit more simplifying we can do, because there's a 5 in the numerator, divided by that 5 in the denominator. And those are going to divide out really nicely. 5 divided by 5 is 1. So then you're just going to have 1 square root of 30, or just the square root of 30. And that would be our simplified answer for that first one. All right, what happens if I have a cube root, like in part B? I've got the cube root of 15 over 32. All right, well, let's see what we have here. First off, when you have a cube root of a fraction, you can take the cube root of the numerator by itself and the cube root of the denominator by itself, okay? 15 doesn't break down very well. It's 5 times 3, so we don't have any groups of 3. But 32 is going to break down quite a bit. 32, you might think about as like 8 times 4. And so 8 is 4 times 2, and 4 is 2 times 2. I'm doing this because I can actually simplify this. I can find a group of 3 to take out. I have 3 2's that can get taken out of it. So the 2's that we have a group for go on the outside. The 2 2's that don't have a group, I'm going to put them on the inside. And I'm doing this on purpose because I want you guys to see what we have and what we need. I didn't do anything to the numerator. Okay, so when I multiply, I want a group of 3 in here. I already have 2 2's, so I just need one more 2 to make a group of 3. So that's what I'm going to multiply in. If I only had 1 2, I'd need 2 more, right? So you're trying to make that group of 3 to take them out of the radical. Whatever you multiply by in the denominator, we're going to need to do the same thing in the numerator so they stay equivalent. All right, from here, we're just going to multiply. Outside times outside, 1 times 1 is 1. Inside times inside, 15 times 2 is 30. So we'll have the cube root of 30 in the numerator. In the denominator, what's going to happen is we're going to have a group of 3 2's. So they're going to come out of the radical as a 2. They'll multiply by the 2 that's already there. And 2 times 2 would be 4. That's all we can do. In case you're wondering, can we simplify the 30 and the 4? Nope, because the 30 is inside a cube root and the 4 is not. So this is all we can do on that one. All right, C has some fun variables. It's always nice to have some variety with our examples. So in part C, I've got a fourth root of 6y over w squared. And we're just going to assume that all of our variables are positive so that we don't have, we're not dividing by 0. We're not having a fourth root of a negative number. Everything is going to involve a real number at the end. Okay, so that's why they kind of put those stipulations on our variables. So from here, let's see, we've got the fourth root of 6y in the numerator and the fourth root of w squared. I'm just going to expand that out so you guys can see we already have 2 w's, okay? So in a fourth root, we're looking for a group of 4. We already have 2 w's, so how many more are we going to need? You're right, we're going to need 2 more. We need 2 more to make that group of 4. So I'm going to multiply by 2 w's in the denominator, and I'm going to do the same thing to the numerator so that they stay equivalent. All right, from here, multiplying in the numerator, it'll stay a fourth root. Outside times outside, 1 times 1 is 1. Inside times inside, we're going to have a 6y times w, so that would be 6y w squared, or 6w squared y if you like to rearrange it. Either way is fine. Multiplication is nice and commutative. In the denominator, we will now have a set of 4 w's, which means that that can be taken out of the radical, and we'll just have a w in the denominator. And that is as simplified as we can get on this one. All right, next up, what happens if you have 2 terms in the denominator? What do you do then? This is where we're going to use the conjugate, and I'll show you what that looks like. So in example 3a, we have 7 over the square root of 2 plus the square root of 13. All right. So if you just multiply by the square root of 2, it really wouldn't help you, because then it would help you on the first term, but not the second term. If you multiply by the square root of 13, it would help you on the second term, but not with the first term. You're going to still end up with radicals somewhere. So the way to get rid of your radicals is to multiply by the conjugate. The conjugate looks like the same 2 terms, but we're going to switch the sign in the middle. So we're going to have square root of 2 minus the square root of 13. And I'll show you what this is going to look like. Do not worry. Whatever you multiply by in the denominator, we're going to need to do the same thing in the numerator. Alrighty. When you multiply, you do need to distribute. So that means we're doing square root of 2 times square root of 2, which would be the square root of 4, which is a perfect square. We're going to have square root of 2 times negative square root of 13, which would be a negative square root of 26. We're going to have square root of 13 times positive square root of 2, so positive square root of 26. And square root of 13 times negative square root of 13, which would be a negative square root of 169, which is another perfect square. In the numerator, we're going to distribute again. We're going to do 7 times square root of 2, so 7 square root of 2, minus 7 times square root of 13, so 7 square root of 13. Okay? All right, in the denominator, we've talked about this a little bit. Square root of 4, it's a nice perfect square, right? Square root of 4 is 2. These middle terms, they're going to cancel out. Where you have a negative 1 square root of 26, we have a positive 1 square root of 26, so that would be 0 square root of 26. They're going to cancel out. Minus the square root of 169 is another perfect square. The square root of 169 is 13. So that's what ends up happening when you multiply by that conjugate, is the middle terms cancel out, and the first and last term are perfect squares. Okay? All right, let's see, numerator, we didn't do anything there, so it's 7 squared root of 2 minus 7 squared root of 13. Last thing we can do is actually do our subtraction here. 2 minus 13 is negative 11. Okay? And this answer right here is fine. If it bothers you to have the negative in the denominator, you could move it out. There's a variety of ways you could do the exact same thing. You can move it out front if you'd like to, and have a negative 7 radical 2 minus 7 radical 13 over 11. You could do it like that if it bothers you. You also could just divide, well, basically multiply numerator and denominator by a negative 1 if you would like to, which would give you a negative 7 radical 2 plus a positive 7 squared root of 13 over 11. So there's multiple formats for this correct answer, and any of those are just fine to do. All right, let's do another one. This one has lots of square roots in it, okay? Part B, I've got square root of 3 plus the square root of 5 over the square root of 2 minus the square root of 7. All right, from here, we're going to multiply by the conjugate. So the conjugate for square root of 2 minus square root of 7 would be square root of 2 plus square root of 7. Okay? And whatever you multiply by in the denominator, we're going to need to do the same thing in the numerator to keep them equivalent. Okay? Lots of distributing. In the numerator, we'll do square root of 3 times square root of 2, so that would be the square root of 6. We'll do square root of 3 times square root of 7, so that would be the square root of 21. We'll do the square root of 5 times the square root of 2, so that would be a square root of 10. And we'll do the square root of 5 times the square root of 7, which would be the square root of 35. None of those simplify nicely. None of them break down into pairs that can be taken out. And none of them are like terms. So we're going to have 4 terms in the numerator. In the denominator, we've got square root of 2 times the square root of 2, which would be the square root of 4, which is 2. We're going to have square root of 2 times the square root of 7, which would be the positive square root of 14. We're going to have the negative square root of 7 times positive square root of 2, which will give you a negative square root of 14. And we'll have a negative square root of 7 times a positive square root of 7, which will give you a negative square root of 49, which gives you a negative 7. Whew! So there's all of our multiplication. Let's see, when we simplify things, the numerator doesn't simplify at all. It's just going to stay exactly like it is, because none of those radicals simplified, and none of those radicals are like terms. So it just stays like it is. In the denominator, we'll have 2 minus 7, which is negative 5. And then the positive square root of 14 and the negative square root of 14 are going to cancel out. They'll equal 0 when they are subtracted. So all we have is 2 minus 7, which is negative 5. And that is your answer for part B. Now it's your turn. You get to try one and show me how much you've learned.